studying is indeterminate structures. And you took a course called Structural Analysis 1. You solved determinate structures. Okay, you did with every kind of determinate structures, beams, frames, trusses. في منهم كمان complex truss, we covered complex truss, space truss. When we say determinate structure, the available equilibrium equations are enough to solve the problem or to find the unknown reactions. The available equilibrium equations are enough to find the unknown reactions. You covered at the beginning determinacy, right? We know how to check the determinacy. We calculate the unknowns. How many equilibrium equations we have, we check. If the equilibrium equations is the same as the unknowns, good, determinate. If the available equations are more than the unknowns, unstable. If the available equilibrium equations are more than, less than the unknowns, indeterminate. So there is two terms you covered in structural analysis 1. Easy terms. Determinacy, whether determinate or indeterminate, and stability. Okay, so we check determinacy and we check stability. If the structure is unstable, you don't have to check it. Unstable, it's kind of you forget to tighten something. Something is loose. Something is not restrained in one direction, whether vertical or horizontal or rotation. If you load it, it will rotate. يعني someone will like put a piece of wood, nail it in the wall. If you just apply any kind of rotation, it will rotate. It will not move in the Y or X direction, but it will rotate. So one pin at one end of a member is not enough to provide stability. There is rotation. That's why we have a pin roller to create semi-support or something. Or you can fix one end. Then it will not rotate. No translation in the Y direction, no translation in the X direction, no rotation. These guys, these things, these terms, degrees of freedom, restraints, determinate or indeterminate, we're going to cover it all throughout this course. يعني هذا الكورس تسمعهم a lot of times, you're going to understand them really well. Okay? Still on. So I assume everybody here know how to solve statically determined structures. So I give you a beam that is determinate. You should be able to find the unknown reactions, and most importantly is to construct the shear and moment diagrams. And if there is a frame, shear, moment, and axial force diagram. If there is a term I'm saying or a word I'm saying that you did not get yet, ask me. I understand. Sometimes there's some terms, some difficulty in the English or the accent or whatever. Just stop me. Okay? I'm going to combine. As I'm explaining, I'm going to explain the full lectures in English. Sometimes I do some translation in Arabic, which is something just extra. Okay? So now we are dealing with indeterminate structure. There are different techniques and different methods. We're going to cover 4 major methods. Okay? We're going to start with the force method. Then we're going to go with slope deflection equation, which is a displacement method, and you will see each method have advantage and disadvantage. Pros and cons. Sometimes if you want to do a presentation, you say advantage, disadvantage, or pros and cons. يعني الحسنات والسيئات. Some methods are powerful for this type of structure, whereas it takes a lot of time and there's a lot of difficulty for other structures. You will see this method is good or easy maybe for beams, direct beams. But it's hard when you start talking about frames. The hard thing in this method is how to calculate the deflection. The formulation of the problem is so easy. We're going to make it determinate by removing some of the unknowns to make the structure indeterminate, then introduce each of those unknowns one by one, then solve. In each step, we need to find deflections. Once we write these deflections, I'm going to formulate things as an introduction today. Then we write compatibility. Like at the support, we know there is no vertical deflection. There is the deflection from the first case, plus the deflection from the second case when we introduce one of the unknowns, plus the deflection from the third case should give you zero deflection at this location. This is called compatibility. You can say deflection compatibility or strain compatibility. Compatibility, guys, if there is 2 points are connected, okay, and you calculate the deflection for this location here, it should be the same. give you an example. If we have a column, concrete column, عمود, what do we have inside? Concrete and steel. Concrete column, you see them. They put the steel, then they cast the concrete, right? So it's a composite. Remember now, with concrete and steel. في longitudinal steel, حديد الطولي, في lateral steel. The lateral steel is just to confine the longitudinal steel. Okay? Ties. Stirrups, usually we use this term for beams. Okay? They are ties. Okay? They are ties. That's why usually we have tight column, we have spirally reinforced column. In reinforced concrete one, you're going to cover all of that. The idea is longitudinal reinforcement and concrete. Now listen, the column is usually an axially loaded member. يعني member عليه compression. واسمه column عمود. The main load is compression. It will have bending called interaction. Anyway, assume إنه عندنا column with axial concentrated load, right? This load will be carried by what? الماتيريال الموجودة. With the material we have. Who's going to carry the load? The material you are putting there. You're putting concrete, okay, the concrete will carry part. You are putting steel, the steel will carry part. So they will carry portion of the load. Each will carry portion of the load. For your information, sometimes just 80 to 20%, usually. Not always the case, but usually 80 to 20%. Anyway, so do they carry the same load? The steel and concrete, do they carry the same load? Okay. Do they go the same deflection or strain? Yes. That's what's called compatibility. Otherwise, you have debonding. Same deflection, compatible. Otherwise, they can have debonding. The concrete will go that much and the steel will stay here. Have you ever seen something like that? That's what we call compatibility. Let's just examine to explain compatibility for you, so you see it. Okay? Now, I said they have the same strain at the same location, by the way. At the same location, they have the same strain. يعني عندنا bar موجود جوا الcolumn. There is a bar inside the column. Along that bar, with the concrete around, the bar and the concrete, they have the same strain. Now, do they have the same stress? Be careful when you answer.
بتختلف الاريا؟ مش نفس الستريس لان الاريا بتختلف.
If they have the same strain, the steel and the concrete, do they have the same stress? Yes. Who's saying yes? Who's saying yes is wrong? Who's saying no? Okay, let's see. That's it. Stress is what? Guys, this is Hooke's law. The easiest, the first fundamental concept in mechanics. Hooke's law says sigma equal E epsilon. Epsilon is the same. Stress in the steel will be E steel times that strain. Stress in the concrete equal E concrete times that strain. Which one is bigger, E steel or E concrete? Modulus of elasticity with steel or concrete? Steel. By how much? Give me a number.
25 megapascal للستيل.
Give me a number. E steel, the modulus of elasticity, is bigger than E concrete roughly by how much? Approximately.
22.
8. It's not 8, it's N. Modular ratio. You guys took strength of material sometimes? Okay, forget it. Maybe this is supposed to be in reinforced concrete. Anyway, E steel is how much in megapascal? 200,000 megapascal or 200 gigapascal. Anyway, I'm just maybe taking that to you guys at a higher level because usually I teach reinforced concrete and steel design, but this is structure analysis too. Anyway, that's why the steel for the same area carries almost 8 times the concrete for the same area. And 1 bar of steel can be replaced by 8 of that size, of that area of concrete. Okay? This is what we call compatibility. That's the concept of compatibility. We're going to introduce it here. You will see compatibility means this plus that should give us this. If this location or this support will not move, it means whatever you did to the structure, whatever you did to the original structure should not change this fact. Okay? so let's start explaining this concept by this example. You have fixed at one end and roller at the other end. We have a beam, A, B, and the beam is loaded with uniformly distributed load, W, and let's assume the length is L. So this is indeterminate structure, right? This is indeterminate beam to the first degree. One more unknowns than the available equilibrium equation. Now remember, this beam is one segment. This beam is one segment. So how many equilibrium equations we have? 3. Each segment of a beam should give you 3 equilibrium equations. Each segment is considered a free body. A free body. Okay? Free body gives you 3 equilibrium equations. Fx, Fy, and the moment. A free particle for the equilibrium. How many equations we have? 2. There is no length. There is no need for, in 2D, I'm talking about 2D. There is no need for the moment. There is no length to develop any moment. So Fx and Fy are enough to ensure equilibrium of this rigid particle. Okay? So this is a body, rigid body. Okay? So we have 3 equations of equilibrium. How many unknowns we have? What do we have? We have Ay, reaction in the vertical direction. We have Ax, and we have Ma, whether in this direction or in the other direction. We assume it in one direction, we calculate. If we get it positive, it means the assumed direction is good. If we get it negative, it means the assumed direction is in the other direction. This has nothing to do with the sign convention for the moment. When you find the reactions, let's touch the reactions. When you find the reactions, these directions has nothing to do with the sign convention you covered in structural analysis 1 and statics. Is this positive moment or negative? That's different. Here, just what's the reaction? What's the direction of these? Okay? Once you have them in the right direction, if we get this one negative, it means it's in the other direction. Put it positive in the other direction. Put everything in the same. Go ahead. This? When you calculate the best testable reactions, إذا كان positive موجب, that's the right direction. إذا كان negative, it means the direction الثاني هو الصح. This has nothing to do with the internal forces sign conventions. اللي أخذتوها statics. You did the sign convention for the internal forces. What's the sign convention for internal positive moment? When we design, we don't design for the reactions. We design for the internal forces that are developed in the member due to these reactions and this loading. What's the sign convention for the moment? Someone will say counterclockwise. Wrong. You tell me, depend. You want at the left hand side or at the right hand side? That's a positive moment. That's what I'm saying. Moment, when you draw the moment diagram, this is what your reference. This has nothing to do with it. Okay? I will explain, as I solve examples, I will explain. Shear.
Up and down.
Up,
Down.
clockwise. Yeah. So you come at a cut, you take a cut, and you look at the shear, moment, and axial. If the moment is this direction on the left-hand side cut, it's positive. If I'm looking at the right-hand side, if it's like this, it's negative. It's positive. Otherwise, negative. This is how you evaluate the internal. This is called the internal force. Whether this is shear, V, and this is N or normal. Up, out of the cross section. Tension. In a cross section, compression. It's not a big deal. We know it. But the most important one of them, the most important one is this guy here. Why? Because positive moment gives you tension at the bottom, compression at the top. Negative moment give you tension at the top, compression at the bottom. I'm going to explain this as I go with every example I have. If we are dealing with reinforced concrete, where we put the location of the steel? At the tension side. If we have steel members, we are designing steel members, the member in compression may experience buckling. So the design for compression and for tension, even for the same load, يعني عندك نفس القوة يا جماعة. Acting على steel member. إذا هاي القوة كانت tension ولا compression، إشي بيختلف، كليا بيختلف. Completely a different design if it's the same force. So it's very important to know. Now, shear, what's the stress resulting from shear? Is it tensile or compressive? We have a shear force. We will have a shear stress from the shear force. Equal what? Oh wait. الأكسل النورمال حط فورس أكسل تعطيك ستريس صح؟ عندي لود فورس بي على كروس سكشن. What's the stress? The axial stress.
اللود عليه.
بي عليه. Tension or compression. Good. Now عندي shear. What's the stress resulting from the shear? بكون شبيح اللي يجاوبها.
اللود.
هو لازم يجاوبها بس بكون يعني good one. معدل الفرشور فوق تاو. نسيت تاو. تور. انسى التور في تاو من الشير. طيب اوكي. شو ستريس اللي resulting من البندنج؟ سيجما ايكوال وات؟
ام واي على اي.
ماي على اي. ام واي على اي. الماكسيمم فوق وتحت بيكون ام سي على اي. بس ماي على اي ام واي اوفر اي. طيب الشير نسينا؟ في كيو اوفر اي تي. نسينا؟ في كيو اوفر اي تي. Very important يا جماعة لازم تعرف. هاي يا جماعة هاي الشير ستريس always tension. Whether the shear force is negative or positive, shear always give you tensile force. So when we design for the absolute value. But why it's important to know it's positive shear or negative shear? إذا الاثنين معطوني tensile stress. Why it's important to know this is a positive shear or negative shear? Because positive shear gives you positive moment. Negative shear gives you negative moment. So when you draw the shear diagram, to draw the moment diagram, if it's positive, it means positive. Okay? Now, we're going to draw on the right side. You will see. I'll teach you my way. Don't worry. Okay? I have fundamental concepts. Fundamental concepts. انت وين ليش تحسب الاشياء اللي مش عارف شو بدك تعمل فيها؟ Why you are calculating this? You should know. Okay? التورك زي البندنج. طلع شو حكينا سيجما ايكوال ركز. ام واي اوفر اي. تورك تاو بدل الام تورك. تي سي اوفر بدل الاي للتورك شو بتكون؟ جي. ماشي شيء زي بعض طلع عليهم. What's resisting torque? And remember الpolar moment of inertia. بدك تعمل له twist الpolar resisting. What's resisting moment? The moment is you are bending, you're trying to bend something. Remember is resisting. It's I, the inertia. يعني مرات مش عارف إذا أنا والله ما أعرف أطلع because it has a huge inertia. That's the resistant to any force you have. When you apply tensile, what's resisting? You have tensile or compression. What's resisting? Cross section times E of the material. Cross section and E, not only the cross section. يعني مثلا إذا عندك مطاط ولا حديد تختلف، مع إنه نفس الكروس section. So E and A. Anyway, I'm going to explain all of that. So we have By, right? So we have four unknowns: AY, AX, MA, BY. Someone will say, I know AX. Zero. So you say, okay, there's only three unknowns. You may say, there's only three unknowns. No, you already spent one equation on that. Some X is gone. So we know it, yes, but we don't care. Do we care about AX? Do we care about AX? If it's equal to 0 or not? Why? لأنه هذا structure is what? لأنه هذا structure is what? شو هذا structure؟ نص ولا إيش؟ beam. من الاسامبشنز حتى تحكي انه هذا الستراكشر بيم، بتعرف شو الاسامبشن تبعه؟ اوكي، who can define beam for me؟ عرف البيم، عرف البيم. قول it's a structural member that is loaded perpendicular to its major axis. It's a structural member. The load is perpendicular to its major axis. يعني إذا بحكي لك إنه في load هيك it's no longer a beam. تعرف شو اسمه؟ beam column. It's a frame member. The axial load in beams is very small and ignored. That's the definition of beam. The axial load of the beam, Mohamed, very small. But you see, it's zero. It's zero. If the axial load in a member in a beam is substantial, يعني قيمة معينة رح تعلموها بالdesign courses, it's no longer a beam. You have to design it as a beam column. Okay? طيب حلو هاي. هسه عندنا MA unknown و AY و BY. Okay? أحد يقول لك you know what? نص. Let's give it 50-50. Half here. وهاف here. يعني بيقول خلينا نحط اللود هذا الفيرتيكال نص هون بناء على نفس المومنت. يعني صح اذا حطيت نص هون يعني صار ما يصير you know what هاي بتاخذ ممكن تكون مرتين بدل تاخذ هاي. Sometimes you can predict بس for simple cases. يعني ممكن واحد يقول اوكي ضربة تمشي معه بس not always the case. By the way, the good thing about indeterminate structures, they are more safe than determinate structures. That's one of the advantages about indeterminate structures. They are safer than determinate structures. It's kind of bonus things. You are like, it's like if you wanna secure a frame in the wall, بدك تعلق منظر. حط برغيين كفي يقول إنه خلينا نحط 3 و 4. It's like you are over tightening things. يعني في عندك why? Because they have the ability for redistribution of stresses or loads. يعني if one place give up, reach its ultimate, there will be a redistribution of load or stress. يعني إذا صار yielding here, هاي الجوينت if it's yielding تتحول من fixed لpin يضل stable. يصير عندك semi-supported case. But what's the disadvantage? Costly. It's not easy just to come and build this as a fixed. يعني الحق هاي fixed ممكن يكون 10 مرات حقها بن. It's just مسمار. بدك تعملها fixation تعال الحم تعال مش عارف ايش وسوي. Okay? It's costly. Indeterminate structures are costly. Unless you have to, you never just if you have option, why would you make them indeterminate? Just make them determinate. But sometimes we are forced to have them indeterminate. You will see. The first thing you do in your senior design, مشروع التخرج, is finding the load on the ribs. The ribs are all continuous, so they are indeterminate. So you learn this technique and you use the software. But you, by learning this, بس تتعلمها بتقدر تحكي إن السوفتوير correct or wrong. You can tell whether a software solution is right or wrong. That's why we are learning these concepts. Okay? So this one, look how we can solve this one. This is, can be divided into the following. Is it clear on your picture? Is it clear? Yeah. There we go. You see what I did? I removed BY. Redundant. يعني extra. We call it redundant. يعني زيادة. Redundant. Okay? اسمعها كثير redundant. So I removed this one. Now remember, when I ask you to calculate or to construct the shear and moment diagram and calculate everything. بنحكي عن هذا يا جماعة، هذا الدين تبعنا. أي شيء ثاني إنسان مش موجود في الحياة. Does not exist. It's a tool to solve this. This is the actual beam. So when I say this, you say, okay, that's not our actual beam. هذا مش البيم تبعنا. To make this one equal to this, By as a load, such that the deflection at this point, طبعا هاي will deflect like this, right? Cantilever. Delta B وهاي will deflect like this. We're going to call it delta BB dash. The book used this term and the handouts استخدموا هذا الترم. They use this term.
بصير ثابت الفين وشيء فيكس يعني
كيف fixed؟
يعني
One, you can
بي اخذ النقطه بي ثابته وهو نقطه بس الفيكس
You mean you're gonna keep this, change the fix into pen? Yes, you can do that. Sure. But remember, what did you release? In this case, what did we release? The moment. We release the moment. When we release the moment, you know what we do? We allow for what? Rotation. Now, when we release this, we allow for vertical deflection. يعني when we بس شلنا الزيرو سمحنا بالvertical deflection. بنحل تقدر تعمل اللي بدك اياه. بس there is a technique يعني ممكن نحل هذا مرتين. مرة ريليس المومنت ومرة ريليس الواي. يعني راح احل اسئلة هيك وهيك. You can release any of the unknowns to make the problem determined. هلا هاي determined كل بيعرف يحل هاي؟ Everybody knows. Cantilever beam is the easiest beam. أسهل beam. And this one is determined? You know it's not. I don't know what's By, right? كيف determined؟ أنا مش عارف By. بس أعرف By determined صح؟ Now, this is what we do. Again, so we divided our actual beam into those two cases and we agree this is correct. Given that, we have to write the compatibility equation or the compatibility condition. يعني في عندنا conditions. نعم والله هاي وهذول الاثنين مع بعض nothing will change here. Good. But what will happen here? We want to make sure that the deflection here is 0. ها هون بدي اعمل شيء كالتالي. طلع شو بعمل. بحط unit load واحد. 1 unit load here. I'm going to put 1 unit load here. By the way, the length is the same in all the cases. By is redundant. I removed it. I removed this support. No support. مش support. ماشي؟ But that's not the case. خليك معي. Just wait. Just hold on. So I'm going to put 1 to make calculation easier. The 1 will deflect the beam upward. Something we can calculate, صح? Now I know it's 1. So I can calculate the deflection due to this one equal, the book used this term, FBB. Later on I will tell you why BB. And I say, why not FB? Later on. بعدين بحكي لكم why BB. Okay? لأن مرات ممكن يكون عندنا أكثر من redundant. فبدك تحكي مثلا FBB هو الدفلكشن الناتج عن B من B من اللود عند B، بدك تحكي FBC الدفلكشن الناتج عن B من الرياكشن C. Okay? So later on we're gonna realize why we need to have something like that. Now, can I get this one? Can we get this one? Of course. Okay, we can calculate this deflection. This is a deflection. Can we calculate this deflection? Yes. كيف هعمل فيها يا جماعة؟ بس can we get it? Yes. Can we get this one? Yes. اسمع. إذا حطيت واحد هون I will get FBB. If I put 1 here I will get FBB. If I put BY I will get okay. Yeah. If I put 10 here what do I get? 10 FBB. If I put 100 it's linear. If I put BY I'm going to get BY FBB. The deflection here will be BY FBB. Now look. We have delta B, the deflection due to the original loading after removing the redundant. شايفينها؟ This, from this segment, we have a deflection. Plus the deflection due to dy, which is this one. Delta BB dash, they are equal to 0. Equal what? Equal the deflection here, which is 0. This deflection plus this deflection equals 0. Based on that, you will find By. Okay, طلع. Delta B,
No.
we can calculate it.
So
Plus, what's delta BB dash?
BY is the
It's the deflection in the beam due to one unit load. At that location. At the location where you remove the redundant. عند المكان اللي شلت منه redundant. Now we have to be careful. Now we have to be careful. Some may say, you know what? بدي احطها down, I will put it down. I know this must be equal this. يعني واحد يقدر يحطها تحت لتحت يجي يحكي هاي تساوي هاي. That's fine. If you know what you are doing, that's fine. بس تطلع what we did here. Delta B according to this لتحت ولا لفوق؟ تحت. You're going to assume always the deflection up positive. يعني delta By ايش؟ Negative. Look what how I applied By. I applied By up. The deflection due to By is what? Positive. فراح تكون هاي negative, هاي positive, positive. هسه واحد ممكن someone may come and put this one down. That's fine. But you have to say this equal that. Be careful. When you apply the compatibility, يعني لازم يكون عندك engineering sense اللي حسبتها فوق ولا تحت. مرات صعبة شوي بس يكون structure بس عادة في techniques to get it. Good. Now what's By? Equal delta B. هسه يا جماعة راح تكون تعرف شو By؟ You know what's By؟ هاي deflection على هاي deflection. Okay خلاص. يعني at the end I know the formula is like that. هيك القانون وهيك مش عارف ايه. في الأخير الديفليكشن اللي حسبته هون مع الديفليكشن اللي حسبته هون قسمهم على بعض بيطلع معك الرياكشن. إذا كان عندنا one redundant, one unknown, one extra unknown. Minus. In this case. In this case, yeah.
طيب أنا سؤالي إنه أنا كيف قسمت البيم على أي أساس؟
شو بحكي لك؟ هو later on اسمعوني. Later on you will realize this one will be negative. ماشي؟ This one will be negative and this one will be positive. افهم علي، افهموا علي. الفورميلا هاي اللي أنا حاطها هيك كقانون based على الفورميليشن. دلتا بي بوزيتيف اب. فأنت لما تحسبها راح تطلع معك نيجاتيف راح تكون ماينس ماينس. يعني شغلنا مظبوط. يعني these terms are formulated based on up positive.
أنا سؤالي هون لما إحنا مش كان عندنا determinant قسمنا البيم صح؟ طب أنا كيف بدي أقسم البيم على أي أساس؟ يعني أنا على أساس حطيت هون هذا اللود وأنا ما حطيتش.
ممتاز. So we're saying okay, we're going to make it determinant. What's the easy thing for you? You say لو كان cantilever أسهل شيء علي صح؟ It's your judgment. Your judgment which reaction which unknown to take. أي واحد تشيل. It's your call. مثلا لو كان عندك خلق معي مثلا لو كان عندك هذا pin roller عندك loading أي loading. See we have one more redundant يعني one unknown one extra unknown صح؟ two span beam. Now you may come and say you know بدي أشيل هذا عشان أنا بحب أحل الأوفرهانج بيم. واحد يقول بدي أشيل هذا أنا بحب أحل الستملس أوفرهانج بيم. It's your call. واحد يقول والله أنا بدي أشيل هذا بحب أشتغل منها.
تمام.
يعني you move the redundant عشان تعمل البروبلم as easy as possible.
هسا redundant ما بحط فيه الفورسز اللي بالسؤال نفسه يعني دبليو هون خلص ما بحط عندي redundant.
هسا اسمعني this plus that should give you this.
تمام.
يعني بعمل
يعني when you remove the redundant you keep the actual loading.
تمام.
سؤال when you move the redundant you keep the same loading then you introduce the redundants one by one. طبعا مش redundants unit load at the location of the redundant. unit load وانت عارف انه الريدندنت راح يعطيك the value of that redundant times deflection you get from this one. الاف بي بي شباب they call it flexibility coefficient. ده handout it's a flexibility coefficient. Why? يعني شو عكس الفلكسبيليتي؟
stiffness.
rigidity or stiff ما حد stiff. هذا الموضوع يعني معهم بيقر ولا مش عارف ليش. فليكسبل واحد فليكسبل. الستراكشر نفس الشيء زي flexible or stiff. depend on the stiffness. جماعة stiffness define تعرفوا شو هي؟ stiffness define usually الفورس على الدلتا. يعني the apply force how much I can deflect. هاي stiffness usually stiffness. spring جماعة spring. بتشوف stiffness تبع spring. You apply a force on the spring. If it's so stiff مش راح يعمل deflection. صح deflection تكون قليلة عشان هيك if the deflection small يعني الاي هي صراحة stiffness مش الاي اي او الاي اي اللي كان عندك ترس هي المودلز اوف elasticity. للترسز او للاكسل ممبر اي اي للبينز اي اي على ال كمان حسب اللينك كله اخذتوه بالسترينث ماتيريال لازم تكون اخذتوه بالسترينث ماتيريال. anyway طب اطلع على الاف بي بي عندنا هناك شو هي؟ طلع عليها العكس deflection على طلع جيبها هون bring this one here bring FBB here right تكون دلتا بي على force فإلس the opposite of stiffness is flexibility يعني واحد على stiffness بعطيك قديش flexible واحد على period بعطيك frequency واحد على frequency بعطيك period ماشي next لك زد time 10 يعني خلصت 5 احنا بنخلص صح ولا 10 good so next time we're going to solve 2 examples one example like this one example on this one here the next lecture we're going to solve 2 examples سؤال
يعني دكتور بتشيل redundant force عشان تحول لديتيرمن وبعدين بتزيد الredundant
تحط الredundant ويابلاي كومباتيبل
عشان تطلع فورس عشان يصير
procedure okay remove the redundant to make it